Greetings, everyone. This is Dave with Mighty Line Minute. Today, we're going to talk about one of the elephants in the room, and that's energy. Yes, energy to supply data centers and everything else. We all know in our own communities the problems we have with utilities, especially electrical. But with the data demands that we've got ahead and that we're facing now, we've got to move quickly. Last week, we talked about nuclear fission. Today, we'll be covering nuclear fusion, and I'll get into some of the detail with that. Stay tuned. Chernobyl involved an RBMK reactor designed by Moscow engineers. There was no real containment. Safety systems were disabled, and power surged in seconds, resulting in the destruction and meltdown of a reactor. 3 Mile Island experienced misread alarms and shut off of emergency cooling when it was most needed. At Fukushima, a tsunami flooded emergency generators, resulting in the prolonged loss of cooling, core meltdown, and hydrogen explosions. Designs there had underestimated the worst-case wave. So what's the nuclear waste story? Leaks and aging infrastructure from the 1940s through the 60s in several countries left decades of cleanup. Here's some further facts. High-level waste must be isolated in geologic storage for the long haul, at least 10,000 years, and in some models approaching over 1 million. And that's in order to drop the radioactivity to a natural uranium ore. Plutonium-239 has a half-life of 24,000 years. Think hundreds of thousands of years to really wind down. Cesium-137 and strontium-90 are much faster, from 300 to 600 years. And with cesium-135, think of the term indefinite because safe storage would require well over 1 million years. So what about the next chapter? It's the holy grail that scientists look for, and that's nuclear fusion. Amy, you're on.
Thanks, Dave. I'm truly excited to get into more depth on this one.
Take it away.
You got it. Simply put, nuclear fission, like a large ringing gong, continues endlessly. Nuclear fusion, like a note played on a digital organ, stops the moment the key is released. Nuclear fusion, folks, is a game changer in clean energy. Limitless power, near zero carbon, and none of fission's extremely long waste cycle. Today, the US is leading the charge, with government labs and private companies driving breakthroughs. Let's look at some recent wins, the road to commercial power, and the bills in Congress that could shape fusion's future. The US Department of Energy, DOE, is advancing fusion research by studying high-temperature plasmas to lay the groundwork for future fusion power plants. With a $790 million budget, its Fusion Energy Sciences, FES program, supports Lawrence Livermore and Idaho National Laboratories, as well as Princeton's Plasma Physics Laboratory. These efforts research plasma confinement, material durability, fuel retention, and tritium management. Public-private partnerships are accelerating progress. In 2025, the DOE's Innovative Fusion Research Program awarded $107 million to 6 projects, uniting labs, universities, and industry to push fusion technologies forward. Globally, the US contributes to ITER, the Way in Latin, a 35-nation project in France aiming to replicate the sun's power source, a clean, near-limitless form of energy. Unlike fission, which splits atoms, ITER fuses light atoms like deuterium and tritium to release energy. Its goal, produce far more energy than it consumes, enabling safe, near-zero carbon power. However, cost overruns and delays have pushed full operation to the late 2030s, and some experts think private ventures may get there first. General Fusion, based in British Columbia, is pioneering magnetized target fusion, MTF, a novel fusion technology that uses mechanical compression instead of costly superconducting magnets or high-powered lasers. With recent milestones, including first plasma and record neutron yields, the company aims to deliver fusion-sourced electricity to the grid in the early to mid-2030s, targeting power for approximately 150,000 homes per plant. In the US, Commonwealth Fusion Systems, CFS, is building a compact tokamak in Massachusetts using high-temperature superconductors. Companies like TAE Technologies and Helion Energy are also advancing inertial and magnetic confinement fusion. Recent milestones include the National Ignition Facility, NIF, Lawrence Livermore, where in December 2022, 192 lasers compressed and heated a deuterium-tritium capsule, yielding fusion energy equal to 154% of the laser input. On April 7, 2025, NIF achieved a record 413% of input energy, surpassing ITER's magnetic confinement progress. Private sector advances are also notable. CFS is progressing toward fusion-ready plasma temperatures in new machines debuting in 2025. Princeton is improving reactor safety and efficiency through plasma wall interaction research. Meanwhile, Idaho National Laboratory is developing materials and systems that can withstand extreme temperatures, neutron bombardment, and chemical exposure. All of these efforts aim to solve the engineering challenges of practical fusion power. While commercial fusion is still years away, CFS hopes its Spark, smallest possible affordable robust compact, reactor will achieve net energy by 2027, with grid-connected plants by the early 2030s. Industry projections suggest pilot plants could arrive between 2030 and 2035, with broad deployment by 2040 to 2050, potential $40 to $80 billion market. Skeptics point to ITER's slow pace, while the Fusion Industry Association calls for focused investment to meet the 2040 goal. In the meantime, the Special Competitive Studies Project recommends $10 billion in federal funding by 2030 to secure U.S. energy independence through fusion. And finally, a quick look at recent legislation. The ADVANCE Act of 2024 supports advanced nuclear technologies, including both fission and fusion, by promoting domestic innovation, regulatory modernization, and global competitiveness. The Fusion Energy Act of 2024 focuses on fusion's unique regulatory needs to speed private sector development. The International Nuclear Energy Act of 2025, Senate Bill 1801, is pending in Congress, which promotes international nuclear partnerships. Its companion bill, H.R. 3626, is under committee review. So there you have it, Dave. It's a long and involved road, but one which all of us need to pay attention to, both now and in the years to follow. May I summarize?
Sure, let's bring it home.
The US fusion ecosystem is thriving, driven by breakthroughs and smart investment. With public and private sectors united, fusion can transform energy security, grow the economy, and protect our health while tackling climate challenges. Meeting this promise demands steady funding and strong policy. The time to seize fusion's potential is now, for us and for generations ahead. Thanks for joining us on Mighty Line Minute. Take care.